Good day, grade 9 math students. Our lesson for today is solving about quadratic equation by extracting square roots. Objectives. Find the square root of a number. Solve quadratic equation by extracting square roots. Activity number 1. Find the roots. Direction. Find the following square roots. Number 1. Square root of 16. Square root of 16 is 4 because 4 times 4 is 16. Number 2. Negative square root of 25. So find the square root of 25, that is 5, then copy the negative sign that is outside the radical sign, so we have negative 5. Number 3. Square root of 64. Square root of 64 is 8. 8 times 8 is 64. Number 4. Square root of 121. The square root of 121 is 11. Number 5. Negative square root of 289. The square root of 289 is 17. Then copy the negative sign, so we have negative 17. Number 6. The square root of 16 hundredths. That is 0.4. 0.4 times 0.4 is 0.16. Number 7. This is a fraction. Square root of 16 over 25. Find first the square root of 16, then the square root of 25. So our answer is 4 over 5. 4 the square root of 16 and 5 the square root of 25. Number 8. Positive negative square root of 169. That is 13 over 16. 13 is the square root of 169 and 16 is the square root of 256. Then copy the positive and negative sign. Number 9. Square root of negative 100. What do you think is the answer? The answer is I, or undefined, or I because it is an imaginary number. It is an imaginary number when the radicand is negative. Proceed. We'll have here questions. How did you find the square roots? Does a negative number have square roots? How about the following? Square root of 8, negative square root of 40, negative 6 square root of 60. Are the number rational or irrational? What is rational number and irrational number? Now later, we will discover the answers of these questions. Quadratic equations can be written in the form of x squared equals k and can be solved applying the following properties. First, if k is greater than 0, then x squared equals k has two real solutions or roots, where x is equal to positive negative square root of k. Again, when this k is greater than 0, we have two real solutions. Number 2, if k is equal to 0, then x squared equals k has one real solution or root, which is x equals to 0. Again, x squared equals k when k is equal to 0, it has only one real solution. Number 3, if k is less than 0, then x squared equals k has no real solutions or roots. Again, what are the numbers less than 0? That is negative 1, negative 2, negative 3, and so on. When k is less than 0, it has no real solution. Now we will proceed to the examples. The method of solving quadratic equation in the form of x squared equals k is called extracting square root. Example 1. Solve x squared equals 49. So, we have get the square root of both sides of the equation. So we will have square root of x squared equals square root of 49. Then we all know that the index here is 2 and our exponent is 2. We'll just cancel and we have an answer which is x. So cancel the exponent, cancel the index, we have x and 7. The square root of 49 is 7, then positive negative 7. Since our k is greater than 0, we have two real solutions. The roots are positive 7 and negative 7. Positive 7 times positive 7 will give us 49. The same with negative 7 times negative 7 will give us 49. So the roots are x equals 7 and x equals negative 7. Therefore, the equation has two real solutions. Example number 2. Solve the equation m squared equals to 0. M squared equals to 0. Square the two sides of the equation. So square root of m squared equals square root of 0. Cancel the index, cancel the exponent. So we have m equals to 0. The equation m squared has only one solution. So according to the property, when k is equal to 0, it has only one solution. So in this case, our solution is 0. So m equals 0. So is it clear? We will now proceed to example number 3. Example number 3. Solve the equation y squared plus 9 equals 0. Y squared plus 9 equals 0. First step is we will transpose 9 to the right side of the equation. So it becomes y squared equals 0 minus 9. Why minus 9? Because when we transpose the positive to the right side of the equation, this becomes negative 9. So we have y squared equals 0 minus 9, that is negative 9. The next step is we will square the two sides of the equation. So square root of y squared equals square root of negative 9. Then cancel the exponent, cancel the index, and we have y equals I. Why it is I? Or no real solution, no undefined, because our k here is less than 0. It is negative 9. So according to the property that we had mentioned earlier, that when k is less than 0, it has no real solution. So negative 9 is less than 0. Therefore, this example has no real solution. Next is I'll proceed to example number 4. Solve the equation p plus 15 squared equals 100. So first step is get the square root of both sides of the equation. So square root of p plus 15 squared equals square root of 100. Then cancel the index 2, cancel the exponent 2. So we have p plus 15 equals positive negative 10. Why positive negative 10? The square root of 100 is 10. The square root of no, the square root of 100 is positive 10 and negative 10 because 10 times 10 will give us 100. Negative 10 times negative 10 will also give us 100. Next is we will solve for p in the equation p plus 15 equals positive negative 10. We will separate the positive negative 10. So first is we will solve the p plus 15 equals 10. That is, transpose 15 to the right side of the equation, and we have p equals 10, copy 10. Then this 15 becomes minus 15 because we transpose it to the right side. So 10 minus 15. So our answer is p equals negative 5. negative 5, 10 minus 15 is negative 5. So our first root is p equals negative 5. Next is we will solve the second equation, which is p plus 15 equals negative 10. For the same step, transpose 15 to the right side of the equation. Then we have p equals negative 10 minus 15. So we have p equals negative 10 minus 15, that is negative 25. Therefore, we have the roots or the solution of the equations are negative 5 and negative 25. So there are two solutions, negative 5 or negative 25. In quadratic equation, solutions are called roots of the equation. Next is, we will proceed to solve the equation 3x squared minus 243 equals to 0. 3x squared minus 243 equals to 0. Transpose negative 243 to the right side of the equation. So we have 3x squared equals 0 plus 243. 0 plus 243 is 243. So our numerical coefficient of x squared here is 3. So we divide both sides of the equation by 3. 3x squared divided by 3 and 243 divided by 3. So 3x squared divided by 3 will give us x squared, and 243 divided by 3 will give us 81. Then, square the two sides of the equation. Square root of x squared equals square root of 81. Then, cancel the exponent, cancel the index, and we have x equals positive negative 9. Positive negative 9 because positive 9 times positive 9 will give us 81. Negative 9 times negative 9 will give us 81. Therefore, the roots of the equation are x equals 9 and x equals negative 9. So, is the solutions clear? Now, we will proceed to example number 6. Example number 6. Solve the equation 2x squared equals 30. 2x squared equals 30. Divide both sides of the equation by 2 since our numerical coefficient here is 2. Divide by 2, 30 divided by 2. So 2x squared divided by 2 is x squared. 30 divided by 2 is 15. Then square both sides of the equation. So we have x squared, square root of x squared equals square root of 15. Cancel the exponent 2, cancel the index, and we have x equals positive negative square root of 15. So you'll just copy square root of 15 because 15 is not a perfect square and 15 has no factors, which one factor is a perfect square. Therefore, we can say that 15 is an irrational number. So it is an irrational number. So therefore, the roots of the equation are x equals square root of 15 and x equals negative square root of 15. The roots are irrational numbers. So we have answered already when is the equation has two real solutions, has one solution, or has no real solution, or when is the equation has solution but it is irrational numbers. Now that's all for today. I hope you have learned something from this lesson, and thank you. See you next time.